Hello, this is Mr. Mac. Today, I'm going to talk to you about square root functions and a little bit too about inequalities. First of all, the square root function is something like y equals the square root of x. Now, the square root of x basically says what is the number that when you use it as a factor twice gives you x, or in other words, the square root of 4 is the number that when you use it as a factor twice gives you 4, and in this case 2. The square root of 9 would be 3 because 3 times 3 is 9. But there are a lot of numbers in between 4 and 9, for example, like the square root of 5, which is not a whole number. And those numbers actually turn out to be irrational, and they go on and on. Their decimal expansion goes on and out without terminating or repeating. Now, another way to look at this, though, is like this. If we have the function y is equal to x squared, then its inverse, remember now the steps for the inverse, number one, replace f of x with y. We've already done that. Exchange x and y. So we get x equals y squared, and then solve for y. Now to solve for y, we would want to take the square root of both sides. Don't forget, introduce plus or minus. So we have y equals plus or minus square root x. Now, what does that mean? Well, the original function, let's make this a different color. Let's just make it black. The original function's graph is a parabola that goes through 0, 0, 1, 1, 2, 4, negative 1, 1, negative 2, 4, 3, 9, negative 3, 9. So it looks something like this. Now the inverse, remember, is the graph, this graph, reflected over the line y is equal to x. So it's going to go through 0, 0, 1, 1, 4, 2, 9, 3, negative 1, negative 1, 4, negative 2, 9, negative 3. So it's going to look like this. Now, you can probably see there's a bit of a problem with the inverse because it's not a function. So what we ordinarily do is we define, and that's why we've got the plus or minus there. So what we ordinarily do is we define y equals the square root of x to be the principal or positive root of x. And what that does is that gives us just this half of the square root graph here. Now, if we wanted this half down here, we would think of this as y equals negative square root x. And notice what that does is that reflects our original graph over the x-axis, which is what we know a negative sign on the outside of a function does. So it's all going to kind of fit together. But basically, the square root, the graph of the y is equal to the square root of x is a half of a parabola kind of on its side. Okay. Now, it is kind of important to realize some of the basic points on the basic parent function square root. 0, 0, 1, 1, 4, 2, 9, 3. Now, think about it. Since we're square rooting, what is the square root of 1? Well, 1. What is the square root of 4? 2. What is the square root of 9? 3. So those shouldn't be that difficult to remember. And then you can make the curve because you know what a parabola curve looks like, but it's going sideways rather than up. Okay, and that should take care of the basic part about the graph. Now we do need to also talk about the domain and range of the square root function. Y equals square root x. Now, if we have the basic function, 0, 0, 1, 1, 4, 2, 9, 3. Notice that every x to the right of the origin has a y. So the domain is x is greater than or equal to 0. Now also notice that every value of y has a part of the graph whenever y is greater than or equal to 0. So the domain and range of the square root function is x is greater than or equal to 0 and y is greater than or equal to 0. Now I'd like to show you a mathematical, well, okay, first of all, let's talk about the graph. If you look at the graph, now we're going to treat the square root function as a parent function. So from time to time, oops, I can't do that. Let's just ungroup this. From time to time, we're going to take the square root function and we're going to move it places. Now, the domain is going to be any value to the right of this value of x and any value to the right, and the range is going to be this value for y and up if we got the top half of the curve, or it would be down if it's the negative half of the curve. But getting back to this, there's a way to do this algebraically also, and so let's take a look at an example. Let's say we have y is equal to -3 square root x plus 2 minus 5, and we want to know what the domain and range are. Well, now, first of all, the domain is the values that x is allowed to be. And if we look at the square root function, x plus 2 is underneath the radical. So x plus 2 can't be negative. So we could just start out for the domain to figure it out algebraically and say whatever's under the radical, x plus 2, has to be greater than or equal to 0. Now let's solve that inequality for x. Subtract 2 from each side, and we get x is greater than or equal to -2. And that would be the domain of this function. Now, that's pretty straightforward. That's not all that difficult to see. Now, the range, however, is, this is pretty cool, but you're going to need to think about this some. See, now, we define the square root to be the principal or positive value. So anytime you see a square root, the value you're going to get is going to be greater than or equal to 0. Now, what I'm going to do in this case is I'm going to make this side of the inequality look like this. In other words, these are the directions. This is what I'm going to do. First of all, I'm going to multiply both sides of the inequality by -3. So I can have a -3 in front of that. That's -3 square root x plus 2. And on this side, I have 0 times -3. What is that? Right, still 0. But what happens to an inequality when you multiply both sides of the inequality by a negative number? Why, inequality flips directions, so we would say less than or equal to, right? Now, we're not quite there yet. We need this -5. So what I'm going to do is I'm going to subtract 5 from each side of this inequality. That gives me -3 square root x plus 2 minus 5 is less than or equal to 0 minus 5, which is -5. Now, look at this, and this is cool, okay? This, -3 square root x plus 2 minus 5 is y. So over here, I've made this -3 square root x plus 2 minus 5. And what is that? Why, it's y. So we can put y in for it and say y is less than or equal to -5. And that is the range. You'll see this a number of times in the solution videos. I kind of hope you enjoy it. All right, now, one other thing that we do need to talk about, and we may as well just use this function. So why don't we clone this and throw it down? Oops, it's bouncing. And put it down here and talk about this as a parent function. Okay, now, see, y is equal to the square root of x is our parent function. Now, this plus 2 is a 2 that's being added to x before we perform the function. Now, that means it is a left-right shift. And remember, when we do that before we perform the function, we always think of that as opposite the direction we would expect. So plus 2 will be 2 to the left. Okay, now this negative sign is multiplied by the function. So, and that's after the function has been performed. So this is a reflection over the x-axis. Okay, and the 3 is a multiplication after the function. It is a vertical stretch of 3 units. So something that before was 1 unit above the horizontal axis will now be 3, et cetera, et cetera, et cetera. And then finally, this minus 5 shifts the whole thing down 5. So if we were to actually graph this, we would start with, for example, an xy axis, and we would have the square root function 2 to the left. That's the plus 2. Then the negative sign would shift it so that it's actually reflected over the x-axis. Now the 3 would make everything below the x-axis 3 times as far below as it was before. And then finally, the minus 5 would shift this whole thing. Let's see, can I get this one? Would shift this whole thing down 5 units. And so this would end up being the final placement of the graph. Now, if they ask for the domain, notice x is greater than or equal to -2. Range, y is less than or equal to -5. You could also get that algebraically. In fact, we did up here, I think. X is greater than or equal to -2, y is less than or equal to -5. But you can read it from the graph as well. So these radical functions, these square root functions, actually do behave just like the transformations that we're used to seeing. Now, one more thing. We do also want to talk about radical inequalities. If we have y is greater than the square root of x. Now, one of the concepts that we've looked at over and over again is that whenever you're graphing an inequality, you're going to graph the graph or the curve that is the actual thing that you'd have here if you put an equal sign in. And then you either do it solid or dotted depending upon whether you have the or equal to or not. And then you shade on one side or the other. In this case, there's something a little bit different. First of all, I'm going to make it dotted, and here's the curve, or an approximation of that curve. Y is equal to the square root of x. Now, the square root of x is not defined for any value to the left of x equals 0. So nothing over here gets shaded because no x over there. So we're going to shade above or below this curve, but we're not going to be shading to the left of where the curve starts, because no value for no ordered pair over there has an x that's defined in that inequality. Now, remember, the way we did this ordinarily we would pick a point that's not on the curve. And perhaps an easy one to choose here would be the point 4, 0. And we put the x and y's in. So we get 0 is greater than the square root of 4. Well, that's 0 is greater than 2, and that's not true. So we don't want the side that contains that point. That means we want the other side. So we will shade above the curve on this one. And that's basically how you do inequalities. You find the curve where the curve is using parent transformations, whatever you need to do, and then pick a point above or below the curve, not to the other side of the curve, and put it back in the original inequality. If it makes it true, that point's on the side you want to shade in. If it doesn't, you want to shade the other side in. But don't go past the vertex of that square root function, or you have included values where the x's are not in the domain. Now that pretty much takes care of square root functions and square root inequalities.